Okay, this is lesson 97 in Algebra 1 called Angles and Triangles, Pythagorean Theorem, and Pythagorean Triples. Angles and triangles, the first couple pages there, they're just discussing what an angle and what a triangle is. Not really interested in you learning at this point the official definition. You pretty much know what an angle is, right? And you pretty much know what a triangle is. So I'm not going to go into a ton of stuff there, but there is a certain kind of a triangle that we're going to talk about called a right triangle. And a right triangle means that there's a little square in the corner of the biggest angle, and that biggest angle is always 90 degrees. And they call it a right triangle. I have no idea why, but it makes a 90-degree angle right there. We don't care what the other angles are. If that one angle, the biggest one, is a 90-degree angle, it's called a right triangle. And that brings us to a theory, or a theorem, that you've learned probably in the past. A squared plus b squared equals c squared. And that's the Pythagorean theorem. And what that means is, it doesn't matter what side A and B are as long as they're not the longest. C is always the longest side, or what is called the hypotenuse. Okay, that's an S there. The hypotenuse is always the longest side, and it's always represented by C. The other two angles, A and B, doesn't matter if you call them A and B like that, or A and B like that. It does not matter. But what it's saying is, if we take the length of one side and square it, the length of another side and square it, add them together, we will get that squared. So for example, if this is 3, this is 4, and this is 5. So if we take one of the sides and square it, plus another side and square it, we will get the longest side squared. Whoops, that's supposed to be a 4, isn't it? So we get 9 plus 16 equals 25. Is that a true statement? Yes. Then that means that all works. So what if I was given an angle and I was told this was x, this was 4, and this was 5? Well, I know that if we take the length of one and square it, the length of the other and square it, we're going to get the hypotenuse. Keep wanting to just square it. Squared. So x squared plus 16 equals 25. X squared equals 9. So x equals what? 3, because we take the square root of both sides. And we don't get plus or minus 3 like in the last lesson, because we're looking at the length. Lengths are always positive, so you will never get a negative length. So there's my x right there that I was looking for. So that's the nice thing about the Pythagorean theorem, is you can find the values of different sides of the triangle when you're not given all of them. So for example, if you have this tree and you want to find out how tall the tree is, and you don't know that, but you do know how far you're standing from the tree. Let's not make it a big number. Let's make it 6. No, let's not make it 6. Let's make it 8. And you, for some reason, know the length of that thing here, and you find out that it is 10. And you're trying to find out the height of the tree. So that you don't know that. So if we take the height of the tree that we don't know and square it, the other short side and square it, we get the hypotenuse squared. So h squared plus 64 equals 100. So 8 squared equals 36. So square root of both sides, h square root of 36 is 6. So I know this tree is 6 feet high. Okay? So you can find out how high or how long different things are using the Pythagorean theorem in order to do so. Alright, so that's pretty much what example 97.2 is. Let's look at 97.3. It gives us this length, and if there's not a little square there, you assume it's not a right angle and you can't use Pythagorean. So that little square has to be there to show that it's a right angle, because Pythagorean only works on right angles. So k squared plus 5 squared equals the square root of 61 squared. So k squared plus 25. What is the square root of 61 squared? It's just 61. So k squared equals, is that 36? Okay. So square root of both sides, and we get k equals plus or minus 6, but since we're looking at the length, it has to be positive. Okay. And let's just keep looking at a couple more of these. I'm not sure why they give so many examples, but we get 12, 8, and m. Okay, so our Pythagorean theorem says 12 squared, a short side, hypotenuse. So this ends up being 208 equals m squared. Square root of both sides gives me m equals the square root of 208. And then my job is to break that 208 down. So let's go ahead and use our factor tree. 52 to 26, right? 13 and 2. So we have a 2, a 2, a 2, a 2, and a 13. So m equals the square root of 2 to the 4th power, since I have 4 of them. Okay, and remember how to simplify these. There's an assumed 2 there. How many times does 2 go into 4? Twice. So I pull out 2 of the 2's, and I have none left over, so I have none left inside there. So 4 square root of 13 is the simplification of the square root of 208. Alright, this next section is called the Pythagorean triple, and what that means is if any triangle we have that's an integer is going to be of the multiple 3, 4, 5. Okay, so we have 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. 25 equals 25. And that being a true statement means that those numbers work. Or any multiple of those numbers. So if we took the 5 times 2, the 3 times 2, and the 4 times 2, we get that. And that works because 8 squared is 64 plus 36 equals 100. Okay? So any multiple. And a lot of my friends that are in construction use this rather than the whole Pythagorean theorem. And there's a lot of interesting ways when you're building a house that you have to use the Pythagorean theorem. Another one. So if we look at the 3, 4, 5, let's multiply it by 4. So that would be 20, that would be 12, and that would be 16. Okay, so anytime it works where you have a multiple of the 3, 4, and 5, it's going to give you a Pythagorean triple, and that's just what it's called. You can have all kinds of Pythagorean triples. There's all kinds of them out there. Let's see, there is the 8, 15, and 17, because you've got 64 plus 225 equals 289. And do those equal 289? Yes, they do. So that means that is a Pythagorean triple. If these two squared and added up give you this squared, then you've got a Pythagorean triple. So there's lots and lots of them out there. And again, if they give you, like in the practice problems, they give you, let's see, do they give you a Pythagorean triple? Yeah, number 8. And they're asking you to find the unknown length. Alright? So, if we have that, we take the two short sides and square them, and that gives us the long side squared. So 25 plus 144 equals c squared. So this ends up being 169 equals c squared. Square root of both sides gives you a c of 13, because the square root of 169 is 13. That's why, hopefully, when you had algebra or pre-algebra, I guess maybe you didn't. I know Miss Tristan and I usually make you memorize all of the square roots from 0 to 400 up to 20, so you can just look at 169 and say, oh, the square root of that is 13, or oh, the square root of 225 is 15, or oh, the square root of 256 is 16. It just makes it a lot easier. You don't have to take your calculator out and figure it out. So anyway, this is lesson number 97, and that's pretty much it.